So, ladies and gentlemen, our last keynote for today will highlight on railway systems. There are large and complex networks, so many different of component systems, including human, mechanical, electrical, and telecommunication infrastructure, must operate reliable and simultaneously. So, introducing supervisory control and data acquisition systems that provide visibility of failure conditions in complex systems. Here to share, please welcome the Dr. Hairulazwan bin Hashim.
Thank you very much for to the moderator. Assalamualaikum warahmatullahi and very good morning. Can you hear me?
Yes, we can hear you.
Okay, thank you very much. Assalamualaikum and good morning. My name is Hairulazwan Hashim. Currently I'm a head of Industry Center of Excellence for Railway ICOE Rail from the Fakulti of Engineering Technology UTHM. So first of all, thank you very much for the organizing committee by giving me a chance and opportunity to give a keynote speech. So today I will share my experience and knowledge regarding to the visualization of supervisory control and data acquisition or SCADA in the railway application. This is the outline of my presentation. So I will begin with some introduction. Visualization of SCADA dashboard project in the railway application, and then share some research collaboration between UTHM and industry, and then I will conclude my presentation. So hope you can enjoy my presentation. So this is industry revolution. Everybody knows about the revolution of industry. So it begins with the industry 1.0. So revolution 1.0 began with the mechanism and steam and water power. Later, the second revolution implemented electricity, mass production and assembly lines, third industrial computers, automation and electronics. So the first three revolutions transformed the way society is working and living. Now companies are more productive and efficient due to new machinery, new power sources, and new ways of arranging works. So we are now in the midst of the cyber revolution, often known as the Industry 4.0 or cyber physical system intelligence. So the first revolution is about machines replacing humans and transforming manufacturing into IoT, integrated smart facilities. It means at the Industry 4.0, focusing on artificial intelligence, AI, computer-based systems, cyber physical, networking and cloud servers, machine learning, 3D printing, autonomous, and so on and so forth. So Industry 4.0 is not fully incorporated yet. So why do people already talk about Industry 4.0? Whereas Industry 4.0 was about connecting automation and digitalization, Industry 4.0 collaborates between humans and machines. Therefore, through automated manufacturing, the transportation sector, including railway and airways, will realize the efficiency, capacity, and cost benefits of Industry 4.0. There's no established path for the success of any emerging technology, but creating roadmap can help the rail and aviation industries to bring more digital and connected future. So the need for these industries to be is there because the first generation of industry activity ensures reliability and safety in these sectors. So with automation of the manufacturing industry, this sector will realize the efficiency, capacity, and cost base of Industry 4.0. Enhance industry-wide condition monitoring will also help reduce unplanned maintenance. Both sectors are in constant search for improvement to deliver better and secure customer experience. So transportation systems are complex with respect to technology and operations due to the involvement of a wide range of human actors, organization, and technical solutions. So there is a need to apply intelligent computerized system for the operation and control of such complex environments, such as computerized traffic control system for coordinating railway transportation. So technology like artificial intelligence, AI, big data and connectivity and autonomous driving will impact the industry. So these technology are creating a new environment which will be benefited all rail operators, manufacturers and passengers. So with the combination of tiny sensor throughout the track and switching system, information can be immediately analyzed by AI and big data to proactively predict maintenance needs, avoid incident or delay, and so improve both safety and operational efficiency. So as an example, so the Tails group is now, the Tails group is now in the process of transforming digitally the railway industry, such as rail signaling, passenger safety, and passenger services. So digitalization in the train sector can seem a daunting challenge for rail operator, but the Tails team utilize the power of digital technology to help their customer opportunity for cost savings and service improvement, from smart infrastructure to passenger experience, from cybersecurity to train and metro autonomy. So digitalization allows for the collection and use of data as never before. Modernization of the railway industry, reducing costs, ensuring the reliability of processes, and optimizing the availability of trains. So area of application, spare parts and maintenance planning, obsolescence monitoring, prediction of failure, specific instructions, and technical documentation, access to remote expert, e-learning, and much more can be explored. Therefore, digitalization raises efficiency in both daily activity and long-term planning. So figure illustrates the dynamic maintenance planning from the Alstom team. So figure illustrate how Alstom teams represent an innovative approach to condition-based and predictive maintenance for rolling stock, infrastructure, and signaling. So this integrated range of decision support tools such as sensor, cameras, laser, data logger, and Centra continuously monitor the state of asset to prevent failures, questioning the standard execution of maintenance activity. So smart railways represent a combination of interconnected technological solutions and components, as well as the modern transportation infrastructure like automatic ticketing system, digital display, and smart meters, for example. Likewise, this system requires seamless high data rate, wireless connectivity, and integrated software solution to optimize the usage of asset from track to train to meet the ever-growing demand for energy efficient and safer alerts. So such sensors are able to monitor equipment with the objective of generating alerts about the need for attention on critical element of the train. For example, HVAC management, temperature, passenger information system, diagnostic, crew, HMI management, water tank, inside or outside of the rolling stock, in which it's enabling technology for the IoT for railway. So as shown in this table. So it can emulate any technology, massive data, aggregation, correlation, and analysis using highly sophisticated algorithm have the potential to change operations, maintenance, yield management, and even passenger service in the future. So what is big data? In simple word, big data is defined as mass amount of data that may involve complex, unstructured data as well as semi-structured data. So big data can be classified into 5 S. S velocity, volume, variety, veracity, and value. Velocity means at which data is emanating and changes are occurring between the diverse data sets. Volume refers to the sheer volume of data being generated every second, while there are two varieties of data. It can be either structured, LS, unstructured data. And the data need to reliable and trust. So we need to the process of verifying and validating the data, as well as having access to the big data is all well and good, but the only useful when it has a value. So value of data. So this is the 5 V's of the big data. This is the stage of big data. How we can do a big data analytics. So now let us formally define what is the big data analytics. It examines large and different types of data to uncover hidden pattern, correlation, and other insight. So basically, analyzing the big data is largely used by company to facilitate their growth and development. So this majority of applying various data mining algorithm to the given set of data, which will then aid them in better decision making. There's number of big data analytic tools used to analyze the big data. So for example, Microsoft Excel, even simple basic Microsoft Excel, Microsoft Power BI, Hadoop, Apache, Spark, and some other big data analytic tools. So this is the stages of the big data from the identifying a problem. So we have to define the problem first before we designing the data requirement, what the data means. So for example, when we're dealing with the electrification or rolling stock, then we have to know the technical aspect of the particular component. And then we do a pre-processing data. Either they are structured or unstructured data. Because from the data, we can translate into our meaningful data before we performing the analytics of the various of data. And lastly, we visualize the data. And then for today, I will share the Power SCADA dashboard project, in which we have a matching grant between UTHM and Kejuruteraan Tanah Melayu Berhad KTMB. So the title of the project is a Big Data Analytics in the Railway Industry, Real-Time Monitoring Dashboard for Power SCADA Predictive Maintenance. So it relates for the big data analytics in the railway industry for the real-time monitoring, for the Power SCADA. Power SCADA is for the power. So for the SCADA, usually they have a different type of SCADA. For SCADA on the electrification side, and the SCADA system, signal and com, for the predictive maintenance purposes. So this is the team of the project member. So I'm the head leader of the project, and together with me for UTHM team and KTM team from the IR, Ahmad Nizam Muhammad Amin, Ahmad Sri Yusof from the electrification team. And then we have a Viscon is the supplier for the SCADA system developed for KTMB. So please allow to share video before we begin. So next, please allow me to continue my presentation. So this is the team member. So this is the introduction of the Power SCADA system. So it begins to visualize the frequency of fault status for electrical equipment devices using Power BI dashboard by extracting alarm log from the KTNB Power SCADA master system in real time. So this is real time in 24 hours. So dashboard facilitate the electrification team to visualize of several important input. So we have a several input or location, hourly, daily, monthly, year, device, and description to several graphical output. So we can show, visualize the output such as location, hourly, daily, monthly, and status, description, device, and more. So this interactive tool is possible to analyze the condition of the equipment to predict possible failures that may occur in the near or distant future, and easier to plan maintenance activity and to utilize the equipment more efficiently. So the goal is to study better the organization in order to reduce the time and cost for preparing the maintenance and reporting. So this is objective and scope. Begin with analyze the data, then develop a model using data warehouse, and then set up the additional workstation at the TCC council for KTNB predictive maintenance. So this is the focusing. We are focusing on the several equipment for electrification equipment. We are using real-time data monitoring using Microsoft Power BI software, and we do the data analytics using extract, transform, and load (ETL) of data swing gaming languages such as JavaScript, SQL, and Visual Studio. So this is the architecture of the system. Begin with the data logger, and then this is the conventional method. So they usually record conventionally, manually from the ECC, ECO, Electrical Control Officer, record the data, the fault manually. So by improved method, we generate the monthly report and create the monthly order and then maintenance work progress. So by providing visualize all the data, so it can be advantage to the system uh, in producing in the short period of time. And we don't have any paper to produce, so this is paperless and we can visual easily. And this is the real time update 24 hours, because it's operate 24 hours daily. And the process is by using, as mentioned before, ETL, extract, transform, and load. We can do a processing of the monitoring and supervision. So from this, we can reduce about a 14% time reduction in time and in terms of the time scheduling from the technician. And then this is the Hawaii architecture as TCC. So apart from that, from the big data or IR familiar is a security. We have to confirm that this security level is higher uh, as avoid any hijacking process from other external parties. So this is dotted line represent how we implement. So we install two hub switch, one for server, one for the workstation, in which only one way route from the database storage or server to the workstation. So only one way. I said no both operation. So this is essential organization, additional historical service necessary in order to extract the real-time log. So this new server allow duplication of data storage from the feeder station without interrupting the KTMB operation. So we don't want to disturb the existing system. So this real-time data extraction to require an access permission from the existing Power SCADA system. So the critical part here is the integration with the existing network from the accessibility from the Salak Source Depot. So this is another. Apart from that, TCC is located as a care central. On the other hand, we have a team of the electrification at the Salak Source. So we have to use another network which must be insecure. So this is the device data logger. So the power line, then device status. We transform the data from data center, care central, TCC, care central. So that this data will be duplicated in data storage before feeding to the historical data server and display on the workstation. So we visualize using Power BI software in order to visualize and monitoring. So we can easily do a monitoring of the data. So this is the developed Power SCADA dashboard, in which it has a three page 1, page 2, page 3, where it can be filter several input and output. For example, we can filter in terms of the location, hourly, daily, monthly, year, device identification, as well as to display all the graphical output, such as the location, hourly. So, for example, in this video, if we choose some specific month, so the data will display accordingly. So it easy to monitor and visualize. And later on, is easy to do a maintenance services, either active maintenance or predictive maintenance. And this real-time visualization can be monitored and can be displayed in different platforms, such as in tab, desktop software, and mobile web. So it can show in real time. That's why we need the data to be secured from the KTMB networks. And this project timeline, it begins the visibility study, establish the technical feasibility. Second one is a conceptual design. We focusing on the electrical system overview. We do a site visit. We do a dashboard design and development tools. So phase 3, we do the experimental works. Prepare the outline performance specification, new workstation, how we can model, make sure the system is in line with the current existing system, modeling and simulation design based on the statistical data. We do his data, so the data is from the 2017 until now. There's a lot of data. That's why I begin the introduction with the big data. We dealing with data, so data management, data collection, data analyze, and synthesize the data in order to testing and evaluate of the system performance. So phase 4 is we reporting the findings to the team, KTMB side, and then we launch the project on 10th of March 2022 online due to COVID situation. So this is document presented, produced, signed off an NDA, non-disclosure agreement, in order to make sure the data is secured or non-disclosed by the party. And then we produce the final report as well in the handover, taking over certificate on the 13th of April, 13th of April to the KTMB. And then this is the some of the figure during the process, during the research. We also conduct a training to the staff in order to make sure everybody knows about the data, how to control, how to monitor, how to set up. Because after handing over the certificate, we have a 1 year period liability. And this is the research collaboration between the UTHM industry, some of the research collaboration. The first one is from the research with the Prasana. We try visualize of the signaling and com system in railway application, same as before. This we use pivot table in Microsoft Excel. So we can describe and filter some of the menu of the data, date, variables, location, status, and so on and so forth. So the pivot table allow the user to spend less time operating and maintaining as compared to the conventional method by screening and tracing huge data of failure records manually. So this system, we are visualized of the SCADA system in railway application. So we can filter on the train traction power facility as well as the data alarm set, yearly, monthly, and hourly. We can visualize all the data. So develop this one is also use Microsoft Excel software by using an Power Query and Power Pivot in the Microsoft Excel. So dashboard evaluation performed based on the usability and user experience studies. So in order to make sure our software is meet their expectation, and this evaluation proves that the dashboard can be used effectively and is beneficial to the organization as well as the content towards systematic maintenance. So this one, and next this is called ongoing research collaboration between with i-CMETECH, means from my center to the KTMB staff, the assessment of KTMB driver task, load analysis and driving behavior, factor towards train equipment, wear and tear. We all also focusing on the track works activities. And next one is reliability and safety, as we call as a RAMS. Study on the railway rolling stock, utilizing noise for the rail surface defect detection on the wayside rail site in Malaysia. This one is for the rolling stock. The bottom one is a collaboration with the Center of Diploma Study. We also do engagement for wheel profiling by using a digital recorder. So in order to make sure during the maintenance, it helps operator do it systematically and nicely in order to give a better result in the short time of period. So as a conclusion, the evaluation of the SCADA system has been successfully developed in this research for the collaboration with Malaysian rail operator for the implementation of this evaluation system is in order in other subsystems, for example, signaling, rolling stock, or this one OCS, overhead catering system. So the railway industry is on its way to integrating predictive maintenance and big data. Recent advancement in sensor and condition monitoring technologies have led to continuous data collection and evaluation, significantly minimizing the number of and cost of unscheduled maintenance. I think that's all for my question. Thank you very much. Back to the moderator.
All right, thank you, Dr. Hairul. So with that, we end our keynote session for today. For gentle reminder, kindly ensure all participants scan the QR code for attendance or through link shared in the chat box. With that, thank you, Assalamualaikum, and wish you to have a pleasant day. Bye-bye.